Hello everyone and welcome to lesson 7 on the Save My STEM Physics channel. This is going to be the last lesson on quantum phenomena, and it is about stopping potential, which is in direct relation to the photoelectric effect and quite honestly just the most annoying part of that kind of area in my opinion. So, stopping potential. I'm not going to write this down because it's a very lengthy definition, but stopping potential is the minimum negative potential difference required to stop the emission of photoelectrons from the surface of a metal. Um, and basically, that's because so it's a potential difference of charge. Electrons have a negative charge, so if it's negative to negative, there is repulsion, and therefore the electrons are repelled by a different plate, which I will demonstrate to you in just a second, um, and therefore preventing emission of photoelectrons from the surface of a metal. Um, so to demonstrate this, let's say we have two metal plates here. So those are our two metal plates. They should realistically be parallel to each other, and they are connected by a circuit. I apologize if my blue highlighter runs out. I should be able to get a very quick replacement though. They are connected in a circuit, and we have a voltmeter off to the side just so we can, measure the potential difference and see what the stopping potential is, since the potential difference, as we've seen from the definition, is in direct relation to the stopping potential. So, if we have a negatively charged plate here, so imagine those like negative charges are inside the plate. I obviously just haven't drawn the plate with any dimension. I'll actually just do that for you very quickly. So we have a negatively charged plate up there due to the current flow, and we have just a metal plate here. Metal bonding, as we know from GCSE chemistry, is cations in a sea of delocalized electrons. So there are electrons and negative charges in that, just not as negative as the top plate. Still an overall positive in the bottom plate. So therefore the electrons are attracted to the bottom plate and repelled by the top plate. Now, when the photoelectric effect comes in and we get our incident rays of light, the electrons are liberated from the surface of the metal and they shoot up to just beneath the negative plate. But if the potential difference is equal to the stopping potential or stopping potential difference, then they will not actually hit the detector plate. And the way to think about this is something that Uplearn very graciously introduced to me, was think about if a person throws a ball and the ball is brought back down after getting to a certain height by gravity. And something you should know from GCSE physics is if there are no resistive forces, such as air resistance, the kinetic energy that you sent the ball up with equals, well, I'm not actually sure the symbol for gravitational potential energy. I'm just going to say EG, energy gravitational, because I'm honestly not certain. But those two should be the same. So if there are 400 joules of kinetic energy, then there should be 400 joules at the apex of the ball when it's at its highest of gravitational energy. And the same applies here, where the maximum kinetic energy of the photoelectron is equal to its stopping potential. Now we need to get onto the equation for stopping potential, which is EVS. So VS just stands for stopping potential, and the E stands for charge of electron. which I believe, I don't have a data booklet on me, which I believe is a number that you have to remember yourself. However, it is a very frequently used number in this section of physics, so you'll know it from, say, um, the electron volt video, the first video we did for quantum phenomena. It is 1.6 times 10 to the minus 19. So it's the number that you use to convert from joules to electron volts, and vice versa. And it is also the charge of an electron in coulombs. Coulombs is just a unit of charge. So stopping potential is the minimum. So to find the stopping potential, I'm just going to start writing down here. This is a lead on from that up there. Yeah, this blue highlight is going to run out soon. But EK max over the charge of an electron, E, equals the stopping potential. So if we are told that the maximum kinetic energy is like 1.8 times 10 to the minus 18, and we know that that's 1.6 times 10 to the minus 19, we should get a stopping potential of, if you just let me use my calculator very quickly, we should get a stopping potential of 11.25 volts. If you just see, you can't actually see the calculator screen very well there, unfortunately, but it's just 1.8 times 10 to the minus 18 over 1.6 times 10 to the minus 19. And that's how the calculation works. Unfortunately, to do with the calculation, you need to know the equation yourself. This is not given to you in the AQA data booklet, so you need to know EK max equals EVS. The S isn't actually a variable, it's just a subscript letter to denote stopping potential. We also know from earlier lessons and in the data booklet that EK max equals HF plus phi plus the work function. So we can therefore, minus the work function, EK max equals HF minus phi. And this therefore implies that EVS, so the charge of an electron multiplied by the stopping potential, is equal to HF minus phi, so Planck's constant multiplied by frequency minus the work function of the metal. So therefore, you can solve and find the stopping potential or the work function or any of these variables. Obviously, E and H are not variables, they are constants. You can solve for stopping potential, frequency, or work function using this equation. And that, I believe, is the entire lesson on stopping potential. Oh yeah, I should also, on this diagram, have a cell just to represent, obviously, where the charge is coming from. So yeah, that is stopping potential. It's annoying, it's weird. Think about it in terms of gravity, where the repulsion from the top plate is the gravity acting downwards on the ball or the electron. And that should give you a good enough grasp of an understanding on how stopping potentials interact with electrons. In case it ever asks about how increasing the potential difference may impact things, increasing the potential difference means that an electron that got up to here may only get up to there, so about halfway, or it might end up not even leaving the plate at all. So yeah, that I believe is all for today, and the next lesson we have is the first lesson on particle physics. Goodbye.